So welcome. Thank you so much for tuning in today for the Equity in the Classroom and Research Labs workshop. This session is actually the first of a two-part series co-hosted by the UW Chemistry's Diversity and Equity Steering Committee and the Chemistry Education Group. And I want to just thank Brandy really quick for giving the Chemistry Education Group a chance to join in this hosting event. I'm really excited about this. So the workshops today and next Tuesday will be focusing on making course learning outcomes more transparent to our students and ourselves, and implementing a grading scheme that enables all students to succeed. Before I introduce our speaker, I would like to acknowledge, as the University of Washington, the Coast Salish peoples of this land, the land which touches the shared waters of all tribes and bands within the Suquamish, Tulalip, and Muckleshoot nations. And with that, I'm really honored to welcome today's speaker, Professor Santiago Toledo. Professor Toledo is an associate professor and chair of the chemistry department at St. Edward's University in Austin. He maintains an active research group focused on bio and organic chemistry and also conducts scholarship into teaching and learning practices. Today, he's going to introduce us to Marzano's taxonomy of learning and how it can be employed to develop actionable content-based student learning outcomes, creating a clear roadmap for student success. And next week, we'll talk about an alternative grading method. Please welcome Santiago Toledo.
Thank you, Colleen. Thank you so much for that. And thank you so much for the invitation from UW Chemistry and from everybody and the organizers for this workshops. I'm super excited to be here. I see so many wonderful faces of people that I actually consider my mentors. So it's awesome to see you all. I graduated from the University of Washington with my PhD. I work with Julie Kovacs, doing bioinorganic chemistry. So beautiful stuff. And Northwest UW, dear to my heart. So happy to be here. It's wonderful to see some of you out here. So let me see if we can do the whole sharing thing. That's the first step, right? Let's see if we can succeed at that. Start with that. And then go here. Okay. Can you all see my screen? Thank you so much for confirming. Okay, so today we're going to start, like Colleen was saying, is sort of this two-part story of how my sort of trajectory to how I went about this journey of trying to figure out how to make my classroom accessible to my students, and I'll tell you how that is, why that was necessary. So today we're going to be focused on learning outcomes, and if you're interested and have the time, next week we'll be talking about grading structures and alternative grading structures. So I mentioned a little bit of my background, but I think more importantly, I wanted to mention to you that I don't come from a chemical education background. So as I mentioned, I got my PhD traditional chemistry, and I actually started teaching my academic career right after graduate school in a teaching institution. So I was carrying loads of like a 4-4, meaning 4 classes per semester, even 5 classes per semester sometimes. So some of that pressure, I guess, pushed me into thinking like, how do I do teaching effectively and what kind of things are out there in the scholarship of teaching and learning? So that's kind of my angle. I'm a practitioner like most of you, so I'm hoping to have that practitioner angle as I come across in the different things that we're going to talk about today. So just a few logistics. We're going to have a landing site. Colleen, if you don't mind sharing that link, please, on the chat. So the landing site for the workshop is going to be shared on the chat. So that's where you're going to find the workshop activities. We're going to do a few little reflection things quickly. There's going to be an important document called Insights and Questions. So as you start thinking about stuff and maybe have questions, if you can please populate that Google document with the questions and insights that you might have, and then we can go through those at the end. And then there's going to be some additional resources as well that I've kind of curated for all of you with a little bit of bibliography, as well as some other documents that is just kind of to help you kind of think about this a little bit more deeply. The reason for all of that is because this workshop is usually designed for a little bit longer time. So our 15 minutes are going to feel compressed and artificially real. So we'll see what happens as we go through this whole mess. So for all of you at the end of the workshop, I'm hoping that this will be the things that you will achieve, at least to some extent. So I'll let you read them for a second. And this might actually be crazy ambitious, but we're going to try, okay? So today we're going to talk a little bit about the history and the motivation of how I got into this work. The next stage is going to be the focus of the talk, or like the little bit of the workshop. We're going to talk about the overview of the taxonomy. And then after that, we're going to give you an opportunity to learn about the taxonomy in a taxonomical exercise. So we're actually going to do some hands-on activities in little teams. So you're going to be working with each other on this. Let's get started with that. So first, I wanna get you thinking about some things. So we're gonna do a 1-minute reflection, thinking about the following prompts. So just jot down some notes on the side if you have them, thinking about this prompt right here. Thank you all for taking the time on that. It's just to get us kind of focused on what we're thinking about today. We're going to think about learning outcomes, learning objectives for your courses, and how are these learning objectives something or a tool that you can use to make your course more accessible or more actionable or student-friendly for them. So my goals for my motivations for why I want for my students, the first thing is that I think that learning for understanding and this idea of the learning process should not be a privilege of the few. I think I'm one of the privileged people that somehow figured out how to learn and how to kind of get into the process of thinking about knowledge or about thinking. And that idea took a long time. And for the most part of my career, it wasn't very intentional, right? I wasn't really aware that learning was happening or how learning was happening or when learning was happening. And I think that there's a few of us that can kind of get to that point, but a lot of that secret is kind of hidden from a lot of students. And I think that giving them a little bit of an open door and an advantage to try to get there as soon as possible is kind of a nice thing. So that's sort of a goal that I have for myself in my classes. I also think that ultimately what we want of our students, I think this is kind of a dream for all of us, is that they become self-directed learners, right? So that they can apply knowledge in independent context whenever they have to use that in the right place. They should be able to hopefully navigate ambiguity, like all of us have been able to somewhat do that. So the idea is like, how do we train our students to get ready to do those kinds of things? And how do we do that in a more intentional way? So it turns out that when I first started teaching, my approach was that I was just going to be a tough professor, right? I was just going to be a hard professor with hard, really interesting questions that would be difficult for them to answer. And by osmosis, I thought my students would eventually get there, right? So this idea that if I just pushed them hard, they would actually get there in terms of being able to transfer and understanding. What I was doing is this idea of like, here's some hard questions. And if that happened, I was super happy, right? So my students are amazing because they can answer really hard questions I put together for them. And sometimes I put together the easy questions and they actually got them wrong sometimes. And I was super frustrated. I was like, how can they not get that simple question? It's so easy. They're messing up. I think we've all had that experience in our different experiences in classrooms. But the very strange thing that I had some reflections on, it was me and my colleague, and I'll tell you more about that in a second, was that sometimes students will actually do well on the supposed hard questions, but do poorly in the supposed easy questions. So that was actually quite confusing. If it was on the same topic, that didn't make any sense, right? They should be able to master the easy ones, but maybe do poorly on the harder ones. And that was actually confusing. So digging into the literature, all of the work that you're going to hear about today was actually co-developed with my colleague, Justin Dubas. He's an economics professor. So we were basically really good friends because we were cohort together when we started at the university. And we kind of had a lot of like complaining sessions where we got together and talked about what do we need to do to make our classes better? And between the two of us and a lot of help from our wives, and I'll tell you about that too, we got to kind of some of these conclusions that we came about today. So we did some research, and of course there were some ideas out there for getting our students to do things, learning more effectively through active learning, right? And getting our students to this place of something called higher order thinking. So this idea that certain types of thinking or certain types of learning is actually easier to transfer if the students exercise that effectively. So that was available, and of course work from your colleague there at the University of Washington that sort of pushed a lot of us that were kind of thinking about active learning ahead with a little bit emboldened look and having this paper around to say, look, active learning is actually a good thing, right? So we were kind of thinking that way from our teaching perspective. We also started recognizing that there was something called learning outcomes and backwards designing of your course, meaning starting to think about your course from what do you want your students to learn, and eventually putting all the different pieces of a course together, which is not how I approached the course when I first started teaching. I was kind of, let me put together a syllabus, the distribution of percentages, and then after that, maybe I'll write some exams, and then after that, I'll think about my lessons, right? So it was kind of all backwards and confusing. And I realized that that wasn't necessarily the case in terms of what the literature was suggesting. So learning objectives were done because I had to. The university had accreditation situations, so I had to write learning objectives, right? I was mandated to do that in my syllabus, and I wrote that, and I didn't know what that was for. it was useless for both me and for my students. And I thought that was kind of lack of transparency. I said something on my outcomes, but in reality, my teaching didn't reflect that. And worst of all, I was doing things backwards. I was writing my exams kind of thing, or my assessments that was easy for me to do, I thought. And then I was kind of walking backwards from there and writing my outcomes, as opposed to the other way around, which is what's best practices. So I realized that I had two things that I could actually sort of figure out from my perspective that was under my control. One of them is course design, and the second one is the pedagogy. Today, we're not going to talk about pedagogy, about the active learning stuff that I do in my classroom, but more structure of the course. Like, how do I think about learning outcomes, and how do I think about grading systems, which is what we're going to talk about next week. So what me and Justin did, my colleague in economics, is that we went on a search for a framework. If we wanted our students to be independent and self-reliant and be able to have access to the information in our courses, we needed some sort of mental structure that actually can provide us the framework to then share that with the students and then be able to be very transparent with us in terms of how we design our courses. So if this was important, we needed to figure out some sort of a structure. So Justin and I started looking into the teaching literature. And like I said before, we were lucky enough to be married to K through 12 educators. And every time we had a discovery, like for example, learning the definition of assessments or learning the definitions of learning outcomes for the first time, we came running to our wives and be like, look what we found. And they were like, oh my gosh, you guys are ridiculous. Like, you should have learned that on day one of teaching. What are you doing teaching a classroom, right? We were completely ignorant about a lot of different things. So there was a lot of learning that Justin and I had to do from scratch. And eventually we kind of stumbled upon this idea of Marzano and Kendall's taxonomy of learning, which is what we're going to talk about today a little bit more focused. So the key features here is that this is a taxonomy of learning similar to the one that you might be more comfortable or familiar with, which is Bloom's taxonomy. It's in our opinion, after working a lot with the different taxonomies, Justin and I found that Marzano's taxonomy is a lot easier and approachable for us. At least it just made sense for us. It was intuitive. The taxonomy itself is hierarchical, unlike Bloom's, which is actually one of the challenges of Bloom's taxonomy, that some of those levels in Bloom's, the 6 levels, are actually kind of mingled with one another, so not quite delineated in the case of Marzano. And we also thought that this framework was actually student-friendly eventually. That's something that we can communicate to students somehow to help them think about their own learning process. So this is kind of what we run with, and we use this as our framework. We only focus today, and in my work, I only focus on what is called the cognitive system. But Marzano actually has layers like the metacognitive system and also the self system, which deal with student motivation and student and their self-understanding of the learning, which are completely different. But for today, we're going to focus exclusively on content kind of system, this idea of the cognitive system. So right now, what I'm going to describe is basically the 4 levels of the taxonomy. As I mentioned, there's 4 hierarchical levels in Marzano's taxonomy: retrieval, comprehension, analysis, and knowledge utilization. The bottom 2 levels, comprehension and retrieval, are lower order thinking, whereas the top 2 levels, analysis and knowledge utilization, are higher order thinking. And the idea here is that if students are going to develop the skills to get to higher order thinking, they need to actively be kind of sweeping through those levels of cognition and not just practicing perhaps in the lower level classes, the lower cognition, and in the upper level classes, the higher cognition. This is actually, the suggestion here is that we're kind of sweeping through those and actively allowing our students to have practice with those different levels. So when we look at the lower level, so just retrieval and comprehension, the key idea here for the 2 levels of for the lower order thinking is that students are making sense of existing information. So this is not students creating new knowledge. This is students kind of getting information from a textbook, from a video, from us, from different sources, and then trying to make sense of that information. Whereas at the top 2 levels, the students are going to be creating new knowledge. So it's authentic creation of knowledge at the top. At the lower 2 levels in retrieval, you see things like recognition. So if a student can pick out an item from a list, the idea here is that in retrieval, the student has no idea what that is, why that exists, what that means. All they're doing is regurgitating or recalling or recognizing items from a list. Another idea here in retrieval is that they can do execution of mental processes. So you might be familiar with the idea that some of your students are capable of doing a stoichiometry problem, but they have no idea why there's a relationship between grams and moles or why this substance is related to the other. They can just execute a mental procedure effectively and they get out with an answer for you. That is what we call or consider execution. For comprehension, the student is beginning to bring that information that they have now and trying to translate that into something that makes sense to them. And they can do that through either what is called integration or symbolism. In both integration and symbolism, the student is getting rid of essential versus non-essential concepts. So they're starting to parse out the junk from what they're reading on the textbook or listening from us and deciding what is actually important. In integration, the student is doing this by verbalizing or writing out some extended answer where they're kind of telling us something about why they're understanding the concepts. And in symbolizing, the student is using things like graphical organizers, creating analogies, drawing pictures of a concept. That's when the student is translating information into something that makes sense to them. Again, these two levels are about making sense of existing information. When we get to the top two levels, analysis and knowledge utilization, the expectation is that the student is actually creating new knowledge. So we have under analysis, things like matching, classification. Matching, pretty straightforward. Students are able to mix two things or match two things based on specific characteristics. And this matching is not something that we match for them in the class, but that they have to create some sort of matching criteria to make sure that two things are actually connected to one another. In classification, the student is beginning to put hierarchies and basically this categorization of things. Analysis of errors is looking at an item and thinking about what is right and what is wrong about this particular idea or a problem. You can give them, for example, a developed answer to a problem, and the student will be able to tell you what went wrong with that particular answer or statement. Generalization is taking a bunch of different principles and making a generalization out of that, or by looking at different scenarios and then generalizing from there. Whereas specification is taking the generalizations that we provide to them and then applying that into a particular context. So specification is related to this thinking that goes from broad into specific, and then the opposite for generalization. Knowledge utilization is interesting in that it is no longer about the content. It's now about what to do with the content or how you actually utilize the content into a context that is separate from the content. So the bottom three levels are all about kind of the first two about making sense. The third one is about applying kind of that content. And then the last one is now saying, how do I make a decision with all the knowledge that I have, with this foundation of knowledge I have, how do I put that into action? So let's think about an example from our perspective, let's say as instructors, right? So initially when we started teaching, I really literally had to do and figure out what was a learning outcome. What is a syllabus? What are the components of an effective syllabus? And going through the retrieval level of even recognizing some of those terminology, right? When I went into comprehension, I started making sense of all the different terminology or context about what it meant to do, a 5-minute paper before we started the class, or what it meant to do an assessment or a formative assessment. I didn't know what that meant, or a summative assessment. That's when I started making sense of those things. In the analysis level, I began to sort of crafting my own class a little bit, right? So putting some things in different categories. So I figure out what formative assessments were, and I kind of put my homework there, maybe my quizzes. I started putting them into different buckets. And then the knowledge utilization level is when you're starting to make effective decisions based on, for example, some challenges that you might find in your classroom, right? So if there's a problem that presents in the classroom, something's happening with your students, they're not learning effectively on something, you're now having to troubleshoot and say, given all my toolbox of things in teaching, how do I apply that into the right context? So given that particular example or idea, you can see how difficult it is for all of us that have started teaching, how insane it was for us to be thrown into a classroom and try to do knowledge utilization before we actually had gone through the idea of retrieval comprehension analysis, right? Which is kind of this hierarchy that you kind of have to go through at least somewhat iteratively before you have to go in there and kind of do it. So we've all gone through that and it was hard, right? But ultimately we kind of stumble on it eventually. But if you start thinking about your experiences, this is hopefully how it kind of felt, right? You kind of went through this hierarchy of things. I'll talk a little bit about more examples, perhaps in a little bit about how to describe this for you. But generally speaking, this is what we're looking at. In knowledge utilization, we have the two categories. I wanted to make sure we cover this, the idea of experimenting and investigating. So experimenting is literally the student designing a question, a hypothesis, and then actually gathering data themselves in order to basically find an answer. In investigation is using existing knowledge to then be able to test a hypothesis. So that's more like a literature review, if you think about it, or like using literature to test a hypothesis as opposed to experimenting, which is actually using actual data gathering to test a hypothesis. Decision making and problem solving are very similar to one another. In decision making, the student is figuring out what criteria, what information is essential to be able to do something or do a task. And in problem solving, the students have a roadblock that is presented to them that prevents them from doing that task. And now they have to troubleshoot around that task, but still use the right amount of material or the right content knowledge to be able to answer those questions. So that's a lot of information there, but just giving you a little bit of a broad sense of what those different categories are. Like I said, it's a little bit more intuitive than other things, but this will come with a little bit of time. We're artificially trying to compress this into a small time. But what happened with this taxonomy for us was that it actually gave us finally a framework to think about, how do I write my learning outcomes? Like, it gave me this roadmap of saying, I want my students to start here, and I want my students to reach this level. So I had a clear idea of where I wanted them to be. In my head, it finally delineated this idea of lower versus higher order thinking. Like, it actually became clear, how do I want the students to get to that point? And then I thought that this particular structure allowed the students to figure out how to have a framework themselves for learning how to learn, which I think is the ultimate tool we can give our students. If you can teach them how to learn, then who cares what you put in front of them? They can learn it, hopefully. But having a framework or a mental framework of how their learning takes place was something that I found important. So I do share all of this with my students, and we'll talk a little bit more about that. So my recognitions here were that I didn't know what it meant to be higher order versus lower order when I first started. Marzano emphasizes that this is not an idea of hard versus easy questions, but instead about cognitive control. So basically, how much cognitive control do you put into a particular task? And as experts, sometimes tasks that for students might be higher order because their cognitive control is much more intense, for us, it might be significantly lower. So things and items can actually move into lower order thinking the moment that we have more cognitive control over those particular items. So we might have, over the course of our careers, moved things into lower order thinking because now those things are basically automatic for us. I knew that my teaching at that point realized that my teaching was likely shooting at lower levels, right? So I was not really given an opportunity for students to actually think. And my SLOs were completely missing from that. So now my new level of course design was kind of this idea of, I have my learning outcomes across all the different cognitive levels. And then as a professor, I could choose which cognitive level was my target for my class and for my topic. And then after that, I could then design the assessments and activities specifically mapped to those learning outcomes, and then provide the students this scaffold of how to go from lower order to eventually the higher order that I wanted them to perform in during my exams. So that's how the framework actually helped me a ton to get my class in place. And next week, if you're interested in this, we'll talk about how I leverage these learning outcomes to then now transform the grading structure that I use in my classroom to be able to be a little bit more targeted in the feedback that I provide my students. So to give us a little bit of a break from the idea of me talking, which is not an effective way of instructing, we're going to go into do, at least from me, it doesn't work out very well. And I'm terribly boring and confusing when I talk. So what I'm going to do is let you guys go and do some activities. Okay, so what we're going to do, Colleen, if you can help me out, not quite yet, but we're going to do is we're going to send you into breakout rooms of 4 people, ideally, if that's the case with the audience that we have. And there's going to be, in the landing page, you're going to see some activities for your different breakout rooms. So if you're in breakout room 1, is labeled breakout room 1. You're going to click on that, and on page 3, there's an activity called the retrieval activity. The retrieval activity is for you all to try to do some retrieval, to recall, without looking at any resources that I provided you, all the different levels and sub-levels of the taxonomy, starting with number 1 at the lower cognitive level. And then after that, in your teams, do it silently for a little bit, and then in your teams, actually see if you can fill out the entire list. And then after that, you're going to go to page 4 and 5. And what I want you to do is do some comprehension thinking. So what we're going to do is we're going to try to take the individual sections of the taxonomy, and you're going to try to define it and make sense out of it in your own head. Like, how do you make sense out of comprehension? How do you make sense out of retrieval? How do you make sense out of analysis or knowledge utilization? So Colleen, if you can help me out, how many people do we have right now in the groups? I just want to make sure that we get everybody.
We have a couple people who had to leave, but we've got about 22 right now.
Okay, so we'll do groups of 4. Perfect. And that gives us 6 groups, right? 5 groups.
That's 5, yeah.
5. Okay, so we'll do So take note of this, please, for everybody. So we'll have team 1 and team 2. We'll go team 1 will work on retrieval. Team 2 and team 3 will work on comprehension.
We can send everyone a note once they get to the rooms as well.
Yeah, and I'll send that as well. And then team 4 will work on analysis. And team 5 will work on knowledge utilization. And we'll send that note when we get into the room. So, yes. So now you're all gonna go into that, and we're gonna send you to the breakout rooms. And there's instructions in those activities as well. So if you forget the instructions from the PowerPoint, you can see them in the activity itself. Hi, everybody. So I recognize that this is very short time and we're pulling you out of something, maybe some good discussions that were happening. We have in the landing page an insight and questions document. So that something starts coming up, have that up and maybe start typing it in there. And we're pretty soon we'll be done with some stuff so we can maybe have a conversation about some other questions you have, okay? So now let me share my screen again. We're gonna just talk about a few more things here. Okay, so as I mentioned, this was the structure of course design. You can see how maybe this is useful for writing those outcomes, eventually figuring out what you want to target and decide exactly where you want to be. So I have actually shared with you all as well in the resource page a set of links where you can access all of the different learning objectives I use for general chemistry, for inorganic chemistry, and for inorganic chemistry 1 that we have in our university, and organic chemistry 1 that I've put together because I've taught that in the past. So this is kind of like just a general example of the structure of my learning objectives, right? So it is the goal of what I'm hoping to achieve with my students, and then the things that I expect my students to do with the different content. So this is fully accessible to them. The links that you will see in the resource page are accessible to the students from day 1, and we're actively using this information as a structure for where do we want to be for the assessments, what do we want to accomplish at the end of the class, at the end of the course. So what I can do now that I have this taxonomy, or this idea of the objectives mapped to the taxonomy, first of all, I can kind of begin to do a little bit of lessons for students into what does their own learning look like, right? So what are the different steps for learning? What are some things that you kind of can go through as you're starting to learn? And that's really important for novice learners, right? When they don't have that structure. I can then map all my course activities and anything that I do in my classroom to the learning objectives. So I can tell you what I'm doing on each day, or what each quiz is covering, what each exam is covering, what each homework is covering based on the learning objectives. And what I've done is I've actually leveraged that and then categorized every single question in my assessment according to the learning objectives. And I've actually made that completely available to students so that they can recognize that not all knowledge is created equal. We've all had the experience of a student coming to our office and saying, I swear I understand it, in my own head it makes so much sense, but I don't know how to put it into words, or I don't know why I'm failing at that question. Is because maybe cognitively they can execute the information at a lower cognitive level, and the thing on the exam or the test might be at a higher level, and they're having a hard time doing that translation, right? So we'll talk a little bit about grading on the workshop for next week if you're interested on that. But this is my slide for the dream. I just wanted to share that with you. So imagine now your class, you're finishing up, and now instead of just a grade for the student where you say you got a C in my class, you now have a set of proficiency percentages of the student by different learning outcomes. So the student is able to hopefully more clearly identify which outcomes did they succeeded at and which outcomes they actually did poorly on. We all have had the experience of a student getting a B in the class, and myself, I was a student in that boat, where I got a B, but there were some topics in the class that I had no clue about, right? They left my classroom without any sense of what anything meant, and they didn't have a clue on that objective, but they still got a B. And that's because everything is average, right? So everything kind of turns out. But if we can provide that information for them, where we can say, look, you really screwed up in stoichiometry, let's say, and that's going to be essential for Gen Chem 2 or for the next quarter of chemistry, however you guys decide to do that, the student at least is conscious of their challenges that they had going from semester 1 to semester 2, even if that wasn't something that, even if their grade is satisfactory, they can at least address those things. And as an instructor now, from my side of things, I'm able to then see my bar graphs and say, oh my gosh, I really don't know what's happening on this particular SLO, rather than looking at my average for my exams and then be able to sort of hone in into how can I then change things in my class to actually improve on the instruction that I'm doing for the different outcomes. So you can now parse this out. You can even extend this, and again, this is sort of the dream. Think about an ecosystem of your curriculum where the students will be able to navigate between semester to semester, the connections between the learning objectives, and recognize how they're kind of building on top of one another, or even showing up in different semesters, right? They see it in Gen Chem 1, they might see it again in inorganic chemistry, and they might even see it later on into graduate school. You know, God knows that when I started graduate school, you know, I had no idea what I was missing, and those initial exams that I had to take there or whatever, when I had to figure out what I knew and what I didn't know, I started, the crude reality was I didn't know a lot of different things, but I didn't have a lot of that information. So my goal here, or the idea here, is that with this information available, you can make this available to students, or you can make it available to yourself and have a lot more of a rich data set of information that can tell you more about how your course might be going. So I was hoping to do a little bit for you to think about what are you doing in your classrooms in terms of what kind of cognitive level you think you're targeting, what structures do you have in place right now in your classroom to do this. But I'm going to sort of skip that in lieu of hopefully opening it up now that things are kind of maybe turning in your head, to see if we can kind of have a conversation about some questions that you might have or ideas that came up as you were listening to some of the things that we were doing. So with that, let's open it up, and then we can start.
Thank you so much, Santiago. Clap for our speaker. Thank you for a great introduction to Marzano's. And now if there's any questions out there that have come up, please feel free to, if you want to raise your hand, or if you want to just, I think we're small enough, if you want to unmute yourself and go ahead and get our attention, please go ahead. Oh, Brandy, I see your hand up. Go ahead.
Hey, awesome discussion. So I actually had a meeting earlier today where we were talking about student learning outcomes and integrating DEI related concepts into the classroom. And so one of the faculty members at another school we were talking to, their university basically just integrated two such overall learning outcomes. And one of them was students will be able to explore, critique, and reflect on how chemistry relates to society, culture, and issues of equity and ethics to shape their scientific beliefs and identities. And the other one was students will be able to identify as scientists within the scientific community through constructing peer reviews, engaging in collaborations, and participating in mentorship. And I was wondering what you think about integrating those kinds of things into Gen Chem, or as part of your learning objectives and part of the things that you would map and grade.
Yeah, that sounds beautiful. Absolutely. The structure that I provided here and the way that I have my classroom structure. So for example, general chemistry has 11 learning outcomes for content exclusively, but this doesn't take away from the creative things that all of you do in your classroom. So for example, some of you might have a learning outcome on the literature or proficiency with literature reading, right? Or in this case, as you're mentioning, issues of DEI, and those can absolutely be created standalone. Try to figure out what the structure, again, retrieval comprehension analysis, what the target level is, and then incorporate them into the overall structure of the class. So yeah, it fits really well into that. Another thing that I've suggested to people, sometimes instructors tell me that, well, I don't think about concepts parsed out between concept A and concept B. Ultimately, I want them to sort of bring a bunch of concepts together into one place. That's absolutely also possible within the structure, in that you can write an SLO that's an integrated SLO. So it can be an SLO that mixes SLO 1.1 and 1.2 into the mixed SLO, where you're kind of intentionally describing how those two concepts integrate to one another. So there's a lot of possibilities, and I find that example beautiful, Brandy. That's really cool that somebody's thinking about it that way, and something that easily can be incorporated. And I don't see the taxonomy could absolutely be put into place there as well.
Thanks.
What else? Jasmine, yeah.
I've been thinking, like, I love this, and this is my second Santiago workshop I've been to now, like totally addicted. But I've been thinking a lot about how do we communicate how to learn to students, like not just how to learn chemistry, but I find that a lot of universities aren't explicitly teaching our students that this is how learning works. And I feel like it's a big gap. And at USC, we have like freshman seminars, and I keep going, maybe we need to have, like part of the freshman curriculum be, hey, this is what learning looks like. This is these are techniques to move yourself up Marzano's taxonomy, and here's how to practice. So I don't know if anyone does anything like that, or if you have thoughts on that.
Yeah, like when I, of course, teaching the taxonomy in my class is important. So it's incorporated in my syllabus, and I incorporate it as part of one day in my class where I'm trying to teach the taxonomy. It's not just one day, right? So it's the initial conversation. And then after that is the constant reminder of like, we're doing comprehension today, or we're actually doing analysis thinking, or the questions in the exam are clearly labeled according to cognitive levels so that they can remember what that looks like. So that's my attempt at doing so. But I agree with you that we do a poor job doing that, especially for the people that are the 90% that don't have that structure in mind and ultimately might stumble upon that structure, but is never intentional, right? And that takes a long time for all of us to kind of figure out. This was created agnostic of content in the sense that my colleague in economics and I were sort of thinking about this. So the idea here is, you're right, is that treat it generally as like learning process and learning in general, and then apply that into the context of our chemistry vehicle of learning, right? Whatever that looks like. I think that there's a lot of opportunity there. And if we have, for example, this idea of parse out information for students in terms of knowing what their different cognitive level proficiencies are, we should be able to then tailor, let's say, modules where we say to the student, you keep doing amazing at the comprehension, but the analysis, you keep just doing this. So then how do we put together some activities? And I don't have really a good answer for that. I'm in a very small school, so I can work with students in classes of 32 students. But how do we put together some robust infrastructure so that we can send them and say, okay, if you're missing analytical thinking, let's send you some ideas about how to get there, right? So that's a power that we could actually leverage if we had this parsed out according to those structures.
That's great. Thank you, Jasmine and Brandy, for those great questions to get us started. I see Mike Heineke.
I won't answer the questions from Mike because this brings like flashbacks from the dissertations and stuff. So this is trigger for me. So I will.
That's all of us. I think many of us had Mike on our.
Okay, so never mind. I will actually take the question from Mike. I was just joking. Of course, Mike. Please.
Well, I guess this is really more of a comment. I was struck by what Brandy mentioned about the learning objectives, where I guess I would characterize that as putting chemistry in context and how does it relate to society and so forth. I think that's all really good, but I would caution people that if you're teaching Gen Chem in the first term of freshman year, you're dealing with a large room full of people who just 3 months ago were in high school. And I think that it's easy to overestimate their ability to integrate and to, they're trying to figure out stoichiometry and you're trying to tell them, explain to me why gasoline is cheaper than milk.
Absolutely. I think that
they're over their heads. Also, if we're going to do more of that integrating, which I think we should do, we've got to drop something.
Yes.
The curriculum is too crowded in Gen Chem. You have the tyranny of the syllabus. There are 30 weeks in the year and there are 30 chapters in the book, and you're chained to the oars of the syllabus.
Absolutely, Mike. I absolutely agree. The beauty of the process of having started with thinking about how to intentionally learn write objectives has been that I've been able to really cut back and talk to my department about cutting back on content. The tyranny of the textbook and the syllabus and whatever is available out there ends up creating a challenge for how we actually fit everything in, especially important things as things that Brandy mentioned. So once you begin writing these things and putting them in front of you, you realize how insane it is that we want to teach 25 different ideas with different cognitive levels for all the students that they just landed in our face. So that this process even is a healthy process to just begin saying, what gives in? What cannot be in there? Because there's no time, no room, and these poor students are being like weeded out, just chop their heads because they simply can't handle the cognitive load. So absolutely agree. I think the writing of this was super healthy for me in terms of realizing, forget it, this thing can't happen. But if we think about this and doing this better about how do we teach the students how to learn, they don't need to learn everything, right? Ultimately, they're going to pick it up. We've all picked up stuff as we left our own individual one-on-one training. But if we teach them how to learn, they might have those tools to be able to then facilitate their own learning process. So at least that's the argument. I don't have data to show you that that's true, but that's the argument here. Thanks, Mike.
Thank you. Yeah, thank you. And Mike, I just want to make a quick comment on your point. It's definitely for sure difficult to shoehorn more stuff into 142 in particular. But I think some of the things that Brandy mentioned, or just putting chemistry in context, as you say, could help some students care more about why they want to learn stoichiometry, like just giving them more, making the course more relevant to their lives. And I think at a Gen Chem level, some of the stuff could be treated at, just the first level of the taxonomy, and then maybe revisited in an upper level course in more detail. But so thank you for that. Mark, please go ahead.
Yeah, I have I guess I have a question sort of in how this works concretely, because thinking back, a few years when I was a youth, I'm imagining if I were introduced to these kinds of sort of like, if in my chemistry class I was also taught, about how to learn, I know I would have just rolled my eyes and ignored it, because I'm like, here's some extra words, some extra scaffolding shit that my professor's throwing at me. I don't care. I know how to learn. I know what I want out of this class, which is to get through this class. So how do you deal with that kind of response?
Yeah, absolutely. The attitude is there all the time, and that makes sense, right? They're young, they don't care. They're like, how do I get an A? The constant, first of all, the introduction of that, and the constant reminder and the intentional reminder of how we think about this. And because it's tied to the assessments, I found that to be, of course, the most important hook for them, because they really care about how do I eventually succeed in my class. So as their grades are attached to this idea of succeeding at comprehension or succeeding at analysis. And initially in my classrooms, I had it delineated by point systems where the analysis were worth more than the comprehension. So the students were kind of, in order to get to that A, they actually had to shoot for those higher order thinking. It was one way for me to use as a hook to communicate, oh, if you want to get an A, well, your thinking needs to be a little bit more like this, right? So using it as part of the overall DNA of the course to some extent, right? How that's communicated day in and day out. And the assessment piece definitely helps a lot. They begin to care when you're like, well, that comprehension thing failed. Oh, maybe they don't care. Maybe they're at least trying to figure out like, okay, how do I get a better answer on this? And then I can use the comprehension language to say, this is why this is different than the analysis, right? I don't get complete buy-in at all. And I don't know that I can show you that my students are leaving with a better sense of how their learning process actually takes place. But the use of the language of comprehension, analysis, retrieval in the class, it starts to happen. So it starts to happen. So my students begin to use that language as they describe things to me a little bit better. And another thing that's anecdotal completely is some of the students begin to recognize in other classes how some of the questions were asked at the retrieval level and why they're doing so well on those. And they're starting to sort of analyze to some extent what's happening in other classes. But you're right, I don't have a good answer for that. It's sort of more like it's part of the infrastructure of my course, and I'm trying to intentionally keep embedding that and reminding them of how important it could be. But that's a good point, Mark.
Thank you, Mark. Scott Clary.
Hey, thanks. Yeah, I just had some comments that kind of touched on a lot of this. I guess I'll start with a question for Santiago that struck me. Do you have an idea of is there any one of these four things in Marzano's that ends up being a much bigger focus for you, that you've tend to, I slide towards the analysis, or gosh, comprehension is where I focus, or something like that?
Yeah, so the majority, so in my classes, like for a topic or a particular SLO, day one would be the comprehension level. And then day two, I go into the analysis level, and I sort of always jump between those two. Knowledge utilization is very difficult to achieve under certain conditions, unless I were to do a lot more authentic assessment things. Not a lot of those things happen in the laboratory. They can happen in the research students that I have, and I can be a lot more intentional about that there. But in my classes, starting with Gen Chem all the way to inorganic chemistry, I'm looking at things mostly kind of focusing on this comprehension analysis level. I tend to de-emphasize the retrieval, and I provide with them sort of, here's the glossary of content or terms that are available to you, right? So things like that. And I know that they can find that elsewhere, but I'm mostly focusing like, can you translate that for me? Can you write that for me? Can you draw a picture for me? And then the analysis is more like the application questions. Like, can you now put that into a context that I haven't shown you before? So yes, that's where I kind of emphasize both of those things. And as you'll learn in next week, stuff about grading, it turns out that as I it's clear that the students that are able to do more analytical thinking are sitting more on the A's and B side of things, and the students that are doing more comprehension retrieval level thinking are sitting on the C's and D's side of things. And that's fine. For some of them, that's what they care for, right? They're like, I don't care. The C gets me there, I'm out of here, and that's perfect. But at least we give them, here's what you can shoot for if you wanted to.
Yeah, and if I could just want to make a comment from I think what Jasmine mentioned. I've done a couple of times. There's a freshman interest seminar here at UW that kind of anyone can apply to teach, and I've done one on like decision making and problem solving of like expert versus novice. And because it's for a general audience, I had to take a lot of like the chemistry analysis stuff and generalize it into more general things, and that sort of forced me to abstract it out a little bit and make it more applicable to anybody, because any freshman can take these seminars, and that allowed me to get some ideas that I brought back to the chemistry side of specific examples of like how you differentiate like the answer from the process, so understand that you're learning process and not just learning answers. And so I think when you're talking about how do we teach generalized things, that's something that really helped me, is taking some of these things that I was doing in chemistry and trying to broaden it out and say, how would this be applicable to anybody? And that folded back into very targeted things I can do in the chemistry class at very, very specific spots. And like Mike was saying, I've dropped content when I've taught courses without hesitation, because it allowed me to bring out a decision making or some of these problem solving things that are on the highest level that I could take 20 minutes out of a class and go through and teach. And I think it's important to give yourself the freedom to do that. Give yourself, say, this is a huge thing that I can do to help decision making, and so I'm going to cut this other thing. And I think Santiago has a great point of saying we're never going to be able to cover everything. It's better to cover very important things, but also then take the time to give them tools so they can learn anything else they need to when they get to whatever level they're going to, whether it's grad school or med school or dental or wherever they're doing. Thanks.
Thank you, Scott.
Thanks, Scott. Yeah, great comments. And McCoy.
Yeah, I'll try to keep this quick, but following up on both Mark and Mike's comment, one thing that I've found over the years is that students want a formulaic way to get to the answer. And oftentimes the books actually reinforce it. Their high school learning reinforces it. And Colleen, you're nodding with me on this. But the question is how do you fight that? Because in order to get to the highest levels, they need to be willing to recognize that there's not a simple set of rules that you follow to get from the question to answer. And if you're writing good exams, you should be taking them out of their comfort zone, as far as I'm concerned.
Absolutely. So their exams written at a level that they can actually create new knowledge is the ultimate goal. And some of you probably already write those types of questions, right? Trying to get away from that algorithmic stuff. That would be the execution of mental processes that they're doing at the retrieval level. So they're sitting at that low level. They can throw all these things at us, but they have no idea what that means, why they did it, how they punched it. They just know that they got to the answer. And the burden a little bit is on us and trying to figure out, okay, can we write effective questions? And I've had the pleasure to work with Colleen a little bit now in her team in trying to figure out how to categorize some of those questions that they're using in their classes, those multiple choice questions according to taxonomy. And it's eye-opening to see how students, she's working with students, how students, and Garvit might be here still, I don't know if he left, but how students actually think about these questions is like mind-blowing to think how they find their little way into getting to an answer, without really thinking about the context itself. So it's a lot of work, and it's not, for me, it's definitely not perfect. I'm not there yet. Yeah, it's challenging. But
Yeah.
Sorry, go ahead, Colleen. Go ahead.
Oh, I was just going to say, Garvit did have to go, so he didn't get your shout out, unfortunately. But
great.
Yeah. Thank you. Bye, Mike. And we have one other question from Andrea in the chat, and we are a little bit over time, but we'll hopefully have time for this one. So Andrea asks, what is a reasonable timeline for developing a good set of SLOs? How many iterations of a course did you go through before you felt comfortable with what you had, knowing more refinement could still be done as needed?
Yeah, thank you. And I want to acknowledge and respect all of your time, so I don't feel offended if any of you have to hop off. Please, you have to go, but I'm happy to stay here. Colleen already prompted me and said, if you want to stay here, you can stay here for another half hour. So I'm happy to stay here as long as necessary. but I'm also respectful of all your time. So no offense. Thank you so much for being here if you have to go. So to the question, it took a long time. Justin and I, in my second year of teaching is when we kind of like really hit a wall to say like, this is crazy. Like, we don't know what we're doing. We started thinking about that stuff. SLOs began to be put together maybe in my fourth iteration of the class, third for sure. And then, so that was what, 2012, I think. And I had a huge amount of SLOs. I had like 20 something SLOs. It was just a gigantic number because I was slave to the book or slave to the syllabus or the content. And I was trying to figure out what to do with that. And then in 2016, with the help of a colleague here at St. Ed's, we actually brought that down to like 15 or something, and then brought it down to 11, and then brought it down to now where we are, right? The 11 that are there. And there's definitely some improvement yet to be done. But I would say that it doesn't have to take 7 years for you to get there at all, right? It's more like I changed curriculums, I changed structures, I was learning a lot more. I think that a lot of you, probably a lot of instructors, have already a good set of learning outcomes in place. It's just a matter of now parsing that out and figuring out what level they're actually written at. Let's actually refine it and put some other things below, and then introducing it to the colleagues that are teaching with you and saying, are we really going to do this? Like, are we really committing to this gigantic list of things at the analysis level, let's say, which is maybe where you want them to be, and then starting to sort of parse out from there. It's just a really great conversation to have, and I think a good exercise to start with your classes. But yeah, it's not crazy. It took a while, but it doesn't have to be impossible. I do some of these workshops, and you know, some of the people in your department are experts at this, but I do some of these workshops where we can actually workshop your own learning outcomes, and we can just sit down and go to town and like duke it out and try to figure out what actually is retrieval, what is comprehension, and write those out a little bit. That takes some time, but it's fun. It's a lot of fun.
How much time? So where I'm going with this is we're already planning for next year to really revisit the curriculum. We were going to do it this year, but you know how that went. But I was just trying to kind of wrap my head around what's reasonable for, you know, doing a workshop and kind of, you know, what, if that's something that in a, you know, being on the quarter system, right? Like, is it something where you can kind of go at one class at a time, or is it just a matter of doing a few broad groups of outcomes, and that just kind of how to meter it out, because you can't do it all at once?
Yeah, I mean, with the 100 series, you had the 142, 152, 162 series. I remember, and Colleen has been telling me a little bit about that. That I think should be taken as a package. My thought would be to take it as a package to try to really see the connections across those three. Mm-hmm. And I think during an academic year where you go to those 3 quarters, perhaps, I think that would be a reasonable time frame for saying we're going to sit down with all of these and start to parse those out and write those out and connect them across and decide what's good and what's not good, irrelevant versus irrelevant, doing some comprehension. So yeah, I mean, a course of an academic year would be definitely a reasonable time frame to take care of those three courses. It seems like, you know, especially given the expertise, it seems like you have some people in here that are like super amazing, and it's just I think it's gonna fly. It's amazing how once something clicks, all of a sudden, like colleagues that I've worked with, all of a sudden it just kind of it just slides, right? What you haven't had a framework, and all of a sudden the framework comes in, and then you just run with it, and then it should be easier than what you think, I think.
And when you said that you've done the workshops and you've had kind of this slugfest about kind of just ironing it out, like what is that, a couple hours or what?
Yeah, so we've done it over a period of 3 hours. Thank you, everybody. Thanks, Stefan. Yeah, a period of 3 hours, I think, would be a good sort of getting started point. And then after that, you know, happy to work like every now and then coming in and saying, hey, what do you guys have? Let me see. It's just a lot of fun. Colleen can tell you that we're having a lot of fun with questions, yeah. But SLOs is even more fun, Colleen. So we're having fun with questions. Think about SLOs. That's just even better.
Yeah. Thank you so much.
Thank you. And Andrea, by the way, I do remember, I don't know if you remember me, but I remember you, and it's great to see you again.
I do. It's been a while, and I've seen you at BCCE as well. So yeah, it's good to see you, and I so appreciate all that you're doing and being willing to come back and try and get us moving in a different direction that would be a little bit more supportive of our students. So
thanks for taking the time. Thank you.
Thanks, Andrea. Any other questions or comments? Doesn't look like it. Well, if not, then let's thank our speaker again. Thank you so much, Santiago. This is really great. And also my second Santiago workshop / talk. So, and soon to be 3. So thank you.
Yeah, 50 minutes is tough. So I apologize for the mess, but we're trying to compress it. Hopefully we'll see you next week. I'd love to talk to you about how grading can be incorporated into this stuff. Yeah.